hear or not. If you're able to hear, good. Otherwise, I think there is a small lag. Okay. So non-parametric. Whenever data is not normal, that is when we actually come up with non-parametric equivalent. Or if the data points are very few, to figure out whether the data follows normal distribution or not, and if we have more than two populations, that is when we use Moore's median or Kruskal-Wallis test. In these two tests, we check whether all the medians are same or one of the medians is different. So you compose. Anuj, I'm wearing headphones, so the mic is exactly before my mouth. And I'm speaking at a loud pace. All right. All right. So in non-parametric test, we have two things, Moore's median and Kruskal-Wallis test. We need to come up with hypothesis statements. Null hypothesis says all the medians are the same. Alternative hypothesis says one of the medians or medians is different. Moore's median assigns the data from each population that is higher than the overall median to that group. And all points that are equal to or lower to another group. So suppose we have data sets 1, 2, 3, 4, 5. What is the median here? 3 is the median. So what Moore's median does is it assigns the data from each population that is higher than the overall mean. So higher than the median would be this. It will assign to one group, group 1. Equal to or lower, that is all these 3 will get assigned to group 2. In this way it assigns. It then uses chi-square test to check if the observed frequencies are close to the expected frequencies or not. Next thing is Kruskal-Wallis. We'll do all the practical part as well. Kruskal-Wallis is another test that is non-parametric of ANOVA. Kruskal-Wallis is nothing but an extension to Mann-Whitney test, and it uses the sign rank test. So we have already looked into Mann-Whitney test. Kruskal-Wallis is an extension to this Mann-Whitney test. So for us, all that is important is to understand which test should I use at what point of time. Alright, Kruskal-Wallis test is more powerful than the Moore's median in most cases, that's true. However, Moore's median test handles outliers very well. If at all there is any outlier, then probably Moore's median would be the best bet. Otherwise, you can still go with Kruskal-Wallis. Growth is measured for 3 treatments. There is this sheet that I'm going to open now. Growth, you can consider that as hair growth or whatever be it. It's considered for 3 treatments. Now we want to compare the effect of the 3 treatments on growth. Let's first try Moore's median and then do the Kruskal-Wallis. So let me open EXH_STAT. Just a minute while I open that. Yeah, here it is. So let me open that. Might take half a minute or so, because it has all the statistical packages, right? Each time you open it takes some time. So let me stop the recording for this. I've started the recording once again. So here is the growth and treatment. Treatment 1, treatment 2 and treatment 3. Three types of treatments are given to people and they are measuring the growth, hair growth. Yeah. How are people responding? Okay. Okay, school is closed on Saturday. All right. Yeah. So first things first, let us do Moods median. I go to stat, non-parametrics. I go to, what is that? Moods median test. Stat, non-parametric, moods median test. First time doing that. Response is growth. What do I want to check? Growth. What does that growth depend on? What factor? Treatment. Yeah, and then I simply click on OK. I get a p-value. P-value is 0.004. What does that 0.004 mean? So are you going to accept null or alternate hypothesis? Yeah, you're going to reject null hypothesis. Absolutely correct. The moment you reject the null hypothesis, you're telling that one of the medians is different. You're telling that one of the treatments is different. Not all treatments are the same. There is some difference. Let us see for Kruskal-Wallis what happens for Kruskal-Wallis test. I go to stat, non-parametric test, Kruskal-Wallis. In this also I select growth as response and treatment as factor and click on OK. I get a Z value here as well. Sorry, P value. P value is 0.13. So what do you comment about hypothesis? What do we comment about hypothesis? You reject once again. So you are once again saying that one of the medians is different. So here also we say that at least one of the treatments are different. Here also you say at least one of the treatments is different. All right. Now this particular thing and the flow diagram, these two are very, very important. In this data analysis tool, you have X factors and Y factors. Depending on what is what, you decide, right? Based on if X is Y is discrete and X is discrete, what test are you going to use? You use this 1 proportion, 2 proportion or chi-square. If Y is continuous and X is continuous, use simple regression or multiple regression. If Y is continuous and X is discrete, you use these tests. So in this way you do various tests. Alright, what if Y is discrete and X is discrete? What if both are discrete? You have 3 tests, 1 proportion, 2 proportion and chi-square. If you're comparing one population with external standard, then you use 1 proportion test. If you're comparing 2 populations with each other, you use 2 proportion test. And if you're comparing more than 2 proportions or populations with each other, then you use chi-square test. All right. So analysis of for Y discrete and X discrete. Proportion of having a specific characteristic in population such as percentage defectives, right, rejection rate, etc. always follows binomial distribution. Please pay attention here. This would be important for us. Moving forward, this would be important for us in master black belt, etc. So proportion of having a specific characteristic, that means percentage defectives, rejection rate, etc. would follow binomial distribution. If n samples are chosen at random from a population, I have a population. Suppose I have red balls, yeah, and suppose I have green balls, and suppose I have black balls in a basket. Yeah, if n samples are chosen at random from this population with average proportion of p, so I always pick up 2 balls. Then the number of defectives is given by x is equal to n multiplied by p. This is the formula that is derived for binomial distribution. Estimate of the proportion defective in the population can be obtained by using this formula. This is p cap, by the way, is equal to x by n. Example, there are 100 units which were defectives out of 2000 units sampled. So how many samples do you have? 2000. So x is equal to 2000. How many defectives did you find? sorry, x is equal to, sorry, my bad, n is equal to 2000 here, x is equal to 100 units. So if I simply substitute in this is what I'm going to get. If I want to estimate the proportion defectives, so it will be 0.05% defectives. All right. Start sharing my, sorry, start recording once again. All right, one proportion test example is given. A poll is carried out to find the acceptability of new cricket coach by the people. It was decided that if the support rate for the coach for the entire population was truly less than 25%, the coach would be fired. You'll ask the coach to leave if the support for him reduces below 25%. 200 people participated and 482 people supported the new coach. Conduct a test to check if the new coach should be fired with 95% level of confidence. Simple. Remember these values, 25%, 200 and 482. We will do that right away. Stat basic statistic, one proportion. We need not open anything, but we will do that. All right, here it is. Right? Null hypothesis is proportion is 0.25. Alternate hypothesis is less than 0.25. Well, based on this, you do this. Stat basic statistic, one proportion. Oh, 1 minute. Am I missing out anything? No. I think this is the right one. We have the summarized data basically. We'll have to select that. Number of events we know there are 482. And how many trials are we conducting? 2000. What is the hypothesized proportion? If it is less than 0.25, you sack the coach. So go to options, click on less than, click on OK. These values are given in the question. So we are getting 0.183. What does that mean? What does 0.183 mean? What are you going to do? You accept null hypothesis. What does null hypothesis say? So no, it's given here. Hence we accept the null hypothesis that there is not much evidence to suggest that the support has dropped below 25%. So the coach should not be fired. So let the coach continue. That is what this says. All right. Yep. I would request your help in actually doing these three. Let us read this. In response to serious pricing pressures, a large third-party administrator of healthcare plans has re-engineered its customer service operation in order to reduce cost. The company is concerned that quality of service must not be adversely impacted by the change. The company tracks customer perceptions of service levels using ongoing surveys. Over the last year, the percent of customers who were completely or very satisfied averaged 90%. Right? So now, after running a pilot of the proposed change, data was collected from 250 customers in a random sample. 250 customers you collected. A total of 29 customers responded that they were less than very satisfied. Even though the new process represents a 17% reduction in operating costs, the company is hesitant to launch a new process that may have a negative impact on customer satisfaction. With 29 customers less than very satisfied, should the revised process be launched? Should you launch or should you not launch? Alright, so now Anu, just read this entire thing once again. Yeah. No. 250 is a n value. Number of people who do not like is 29%. Yeah, 29 rest. A total of 29 customers who responded were less than very satisfied. Out of 250, 29 were less than very satisfied. So that is different. Yeah, so read it. And you'll only have to tell me what should we do now. We have to go to stat, basic statistics, one proportion test, number of events, how many? 29 out of 250 people. But you know that if the satisfaction level is 0.10. Why am I writing 0.10, Anush? Any guesses? Can you look at this and say, let me expand this also. Look at this. Over the last year, the percentage of customers who were completely or very satisfied averaged 90%. So 10% of the people were not satisfied. Right? So you want to check whether the 29 out of 250, yeah, based on their statements, are you really not going to launch the process, or are you not going to, are you going to launch the process? You'll have to make a decision. Hope the problem statement is clear. If not, let me know. I'll explain once again. All right. Now, I click on options. Here, one second, Anuj. One second. Hey, sorry, Anuj. There was some other person. All right. So, yep. Let me click on options. Yes, proportion should be greater than hypothesized proportion for you to actually launch the process. Yeah. So, p-value is 0.226. So, what will you say? You accept null hypothesis. Once you accept null hypothesis, what statement are you going to make now? I want managerial statements. Statistical mathematician statements, you have become perfect, right? But now I want managerial statements. So yes, so what do you comment? If you are accepting null hypothesis, you say that percentage of people who are dissatisfied is less than 10%. Hence, we should not revise the process. We should go ahead with the existing process. Yanuj? Okay. Yeah, from now on, we will look into the managerial statements as well. Yes, here comes the second exercise. A company promises delivery within 30 minutes or the customer's order is free. The customer expects 95% of the deliveries to be on time. Proportion of late deliveries should not be more than 5%. The manager observes that there have been a lot of late deliveries recently and wishes to find out if the true proportion of late deliveries is more than 0.05. The manager randomly samples 120 delivery times over a 1 week period and counts the number of late deliveries to be 11. The manager wants strong evidence to reject the null hypothesis because researching the reason for the late deliveries will be time consuming and could even result in employees being disciplined. He selects a 1% significance level for the test. Alright, so Anuj, just internalize this particular problem and then we'll proceed with the exercise. Meanwhile, I'll just write down the null and alternate hypothesis. Yeah, Anuj, let me know once the problem statement is clear for you. All right, you're clear with the problem statement. Simple. Now let me go back to this 120 and 11. Yeah, 11 out of 120 are defectives. What is the proportion? 5% defectives. If it is greater than 0.05% defectives or 5%, then you're going to actually take some investigative steps. All right, no problem, Go ahead. All right, Anuj. So these values for one sample or one proportion test, I have taken these values from the question that is framed, right? And the confidence level is should be different, right? Because here they are telling that he needs to select a 1% significance level for the test. No problem, absolutely. So what is the significance level or confidence level that you have to select? It should be 99%. Yeah, and then click on OK. Simple. P-value is less than 0.05. So if p-value is less than 0.05, what do? You reject null hypothesis. Hence, you're going to make or you're going to go with the alternative hypothesis. What does that say? Proportion of late deliveries is greater than 5%. So what is the managerial decision that you'll take? You'll say that let me proceed and investigate why or investigate the reasons for late deliveries. Yeah, that is the managerial statement that you make. Sample size. How do you decide on the sample size? So here is an example. Percentage of wrong bills dispatched in a credit card company is 0.2%. A consultant has suggested that introduction of auditing shall reduce the wrong bill instances. To decide on initiation of auditing process, a test is to be conducted with 95% confidence to check its effectiveness. If the percentage of defective bills is to be reduced from 0.2% to 0.12%, calculate the sample size required for the test for power values of 0.9. So this is the question, the question can be framed in any way. All you need to do is go to stat, power and sample size, go to one proportion, and you need to enter the values in this way. So go to stat, power and sample test, one proportion, enter all the values. Sample size is not given, alternative values is given 0.0012. Or what is the power value? 0.9, sorry, 0.9 is the power value. Hypothesized proportion is 0.002, and here you give this value as 0.00, my bad, 0.0002, if I'm not mistaken, 12. All right. So these are the values that we need to give. These values are directly coming from the question. Let us see options. Okay, should be less than, and then 0.05. That's it. These values are just coming from the question. That's it. I'm doing nothing. So the sample size should be 21703. That is what is mentioned here, right? Where is that? 21703. We would need at least 21,703 samples to demonstrate that percentage of wrong bills have dropped from 0.2% to 0.12% with a 90% power level and 95% significance level. That is a statement that you make normally. Is it okay to continue, Anuj, or do you have any other work? If you're okay, I'll continue. Alright, I'll do that. At least we can complete another topic. Next thing is two proportion test. Two proportion test is used to compare two proportions of two different populations, such as percentage defectives from two machines, machine A versus machine B. Support rate for two political parties, Congress versus BJP. Right? Whenever you have two, then you use two proportion test. This can be found by testing the difference of two proportions. Suppose there is population 1. For sample size N1, samples with the required characteristic X1, sample proportion would be, this is actually P1 cap, P1 hat, and this is P2 hat. If sample size is N2 and the samples with the required characteristic X2, sample proportion would be X2 by N2. Right? Look at this question, two proportion test example. On auditing purchase department, 17 non-conformities were found out of 155 checkpoints. And when sales department was audited, 23 non-conformities were found out of 200 checkpoints. Find with 95% of confidence if the two proportions are same or different. Also calculate the confidence interval for difference in non-conformities. So simple, you are telling proportion 1, proportion 2 are different. In alternate, you are telling proportion 1 and 2 are, are different. In null hypothesis, you are telling both are same. So you go to stat, basic statistics to proportion. My bad for the spelling mistake. It is to proportion. All right. So let us go to the mini tab, go to stat, basic statistics to proportion. Here we have the summarized data anyways, so we will put that. We have two samples now. Number of events and number of trials we need to write down. Number of trials for first one is 155. Out of that, okay, sorry, number of events is 17 and number of trials were 155. And for sample 2, we had 23 out of 200. Yeah, and then we need to click on options. Okay, estimate the proportion separately. Useful estimate of test. All right, fine. Pool estimate. Okay. We will discuss why I have selected this option when I discuss about the slide. So, wow. P-value is 0.875. If P is high, null flies, so you accept null hypothesis. What does null hypothesis say? Null hypothesis says that both, yes, you accept null hypothesis. Null hypothesis says that, do you know what? Both of the proportions, non-conformities are the same. There is no difference. Look, let us look at this. Why did we select that option from drop down? By the way, this screenshot is from Minitab 16. I'll replace it with Minitab 17 and share an updated analyze phase presentation deck with you. All right. Use pooled estimate if both the proportions came from the similar populations. We got it from the same populations, right? Hence, we have selected that. And also we have 95% confidence interval. Yeah, confidence interval means, or if I want to make a statement that Anuj is going to travel to Australia on 15th January, probability is almost zero. Exactly on that day, maybe may not be. But if I give a range, my confidence will increase. For example, if I say Anuj may travel to Australia anywhere between 10th January to 30th January, then the probability increases. As in how the confidence level increases, the probability increases. So that is 95% confidence interval. So let us see in our Minitab output also the same things. So here we have the confidence interval. All right. Let us do the exercise. Yeah, we'll do this exercise and then we'll break. On auditing 2 pizza outlets, 27 deliveries were late out of 155 in first one, and 22 deliveries were late out of 200 in the second one. Find with 99% of confidence if the two proportions are different. Let us do this. Stat, basic statistics. We are doing two proportion test. Yeah, summarize data itself. So how many events are there? 27 events out of 155. 27 events out of 155. Fine, the first one is fine. Second one is 22 events out of 200. 22 out of 200. Then they are asking us to find out with 99% confidence. So I select this. It's not 90. It is 99%. Then I click on OK and OK. P-value is coming up to 0.082. P high, null fly. What is the null hypothesis? It says both the pizza outlets are delivering the same number of defects or late deliveries. So there is no difference absolutely. Yeah. So